In this problem, we're going to assign the oxidation states for all the atoms in the following compounds. And they give us 6 atoms right here, 6 compounds: potassium permanganate, nickel oxide, iron oxide, copper chloride, the chromate, and the lead oxide right here. We're going to start with the easiest ones so that we see how we're supposed to be doing this. So we're going to start, for example, with nickel oxide. We're not sure about the nickel, but we know that the oxygen, whenever oxygen is in a compound, each oxygen is going to be a -2. So right here, we have 2 oxygens. Each one of them is -2. So it's -4 in terms of the negative charges of the compound. Nickel is a metal, so nickel is going to have the positive charge. And the compound doesn't actually have a charge. They give it to us neutral. So the positives of the nickel are going to completely neutralize the negatives of the oxygens. So if the oxygens are -4, your nickel has to be a +4. So the oxidation state for the nickel is a +4 in this compound. Same thing happens over here with lead oxide. Again, oxygen in a compound is -2. I also have 2 oxygens in this one, so that equals -4. The lead has to neutralize the negative charges of the oxygens. So this lead right here, just like the nickel up here, is a +4. The other one that's very straightforward is the copper chloride here. So chlorides are -1. I have 2 chlorides. So that means that I have 2 negative charges here. And the copper is neutralizing the 2 negative charges because they gave us the compound and it doesn't have a charge, meaning it's neutral. So this copper has to be a +2 so that I neutralize the negative charges of the chloride. So those are the easiest ones. So let's just complicate it a little bit. Let's start with this potassium permanganate because I have the oxygens, but this time I do have an extra positive ion in the potassium. So you start with what we know. We know that potassium, the charge of the potassium ion is the oxidation state of the potassium ion, and that one is a +1. Oxygen is a common atom in the different complexes here. So we know that each oxygen is -2, and I have 4 oxygens. So that's 8 negative charges. So now, the charge of the manganese. The potassium is neutralizing one of the negative charges from the oxygen. So now I have 7 negative charges. And the manganese is actually neutralizing all of them. So we have to have a manganese that's +7. So I have 8 negative charges between the potassium and the manganese, neutralizing the 8 negative charges of the oxygens. Let's do the iron. This one's a little bit different, and you'll see why. Different, but the same. So again, the oxygens are -2. I have 4 oxygens. So that gives us -8. And there is no way I can divide those 8 negative charges with 3 irons and have them all be the same. So we're going to have to do a little bit of creative dividing. So we have 3. So 2 of the irons, 2 irons are going to be +3. That means that we have neutralized 6 positive charges. And there is 1 iron that it's going to neutralize the other 2 charges left over. So 2 of the irons are +3. So that means I have +6 here. 1 iron being +2. That neutralizes the negative charges right there. Chromium right here, way easier than this example because I have 2 chromiums right here. So let's go ahead and remember, by now you remember that oxygen is -2. I have 3 oxygens. So that means I have 6 negative charges, and I have 2 chromiums, so that's easily divided among the chromiums. So 6 negative charges divided by 2, that means that each of my chromiums is a +3 right here. That's the way that you do this type of oxidation state problem. You go with what you know first. We knew the potassium was +1. We knew the chlorides were -1. And we know that the oxygens, which is a very common atom in these compounds, is -2. And then you try to neutralize all the negative and the positives.